Welcome to another episode of Tilly's in a Bottle. Today we're going to look at some things I made that involved hand turning on the lathe. Before we have a look at the projects, I thought I would real briefly just show you how to turn metal by hand on the lathe. I've got a piece of steel in here, and I like to use collets because a collet chuck doesn't have the sharp corners that you get on a 3 or 4 jaw chuck. Usually when you're turning on the lathe, you'll use the carriage and the cross slide, but when we're turning by hand, you'll have your turning tool there on the tool rest, and you just let's start off with a little bit of the past. A long time ago I made this lathe chuck key. I made it to replace this one, which came with the lathe and what was probably the original chuck on the machine. This is clearly homemade and made real quick. This worked, of course, but the handle being so small and digging into your hand got pretty old. My mistake in making this was, even though I made this out of 4140 steel, I didn't heat treat any part of it, and the square part that does the business got chewed up and was no longer any good for tightening up chucks. And so now, to replace those, I've made this one, and I've made it a little nicer looking. I've heat treated the square end, which I think is going to hold up just fine. I also made the handle so that it would be movable. There's a spring and a ball bearing on top of that down in a little bore at the end of this, and so I can move it over here, and that ball bearing is captive and this handle won't come flying out. There's not a whole lot going on appearance-wise on this. The sort of acorn-shaped ends of this were turned by hand, as well as sort of these steps, these round steps, and this ring at the end. I think it's a little bit nicer looking. I can get more leverage out of it by moving it over. The handle on this one I made 6 inches, which is better than the original, which was about 4.5, and certainly better than this thing, which is 2.5. Another project that involved a good deal of turning by hand is this disc type marking gauge. It's a woodworking tool. I know I'm not a woodworker, but this is a gift for a friend of mine who does woodworking. And this is an imitation of another disc type marking gauge called the Tight Mark. Although mine is still a little different from theirs, the Tight Mark doesn't have graduations on the rod, and so this makes it even a little bit more handy. You can actually set your measurement right there on the rod, unless it's less than 1/4 of an inch. The cutter itself is roughly 1/4 of an inch long, and so if it's less than 1/4 of an inch, well, you'll have to get a scale out. We still do have the benefit of doing our coarse setting by just moving it in and out, locking down one of the knobs and spinning the other to fine-tune our adjustment, and then locking that down. And now it's really not going anywhere. The nice thing too is that because it's pretty hefty, maybe it's roughly a pound, you could just use the weight of the gauge itself to do the first cut, and then add on a little bit more weight as you're doing your other marks. The rod is a piece of D1 tool steel. These knobs are stainless, and well, I've used 2 different copper alloys. This is bronze, and these 2 pieces are brass. The adjusting screws are just socket head cap screws that I shoved inside of these stainless knobs. The cutter itself is a piece of air hardening tool steel. These threaded parts are all 1/2 inch 20 thread. And I've designed the whole thing to take original tight mark cutting discs so that the extensions or new discs, when they get worn out, can be just screwed back on. And when you're not using it, the cutter will sit behind this recess, so there's no chipping the cutter or snagging it on anything. One kind of mistake I made was the bore between this end and this end are not concentric, and so when the whole thing is screwed together like that, even though these knobs are loose, the rod will not move in and out. But unscrew either of them a little bit and it'll move just fine. Another fun project was making these two scrapers, the handles for them really. I'm learning to scrape, and so, well, you need a scraper. I decided to make my own. This is my main scraper. It's a 14-inch type. The material is 3/16, and this was the bar from a Fox police lock. It's a kind of heavy lock that you see a lot in New York, where there are two bars that come across either end of the door, and they run on this sort of double rack and pinion. This was part of that bar with the rack. This is kind of like a Sandvik type scraper. It has two screws instead of the one, but it holds Sandvik 630 type inserts. I'm getting a lot of good use out of this. I made the handle, even though you don't start to hold it by the handle until you're quite a ways towards finished scraping or pinpointing. I put the large pad on the end. I find that very helpful. I know some guys don't like that, but I find it helpful for using, what Connolly calls the body power stroke. And then a little prematurely, I made this thinner type of scraper. The material on this is a little bit less than 1/8 of an inch. And this one would be definitely for finished scraping. It was fun, though, making the handle. The handles on both of these are aluminum, which turns great by hand. And this section was fun to make. This was something I saw on a table leg, and I thought I'd try to imitate that. Lastly, what we have is something that might not be too out of place in one of Tubal Cain's What Is It mystery tool videos. This is what I call a rug comb, and when we were in the textile factory in Madrid, we saw some of the rug makers using one of these. My sister is a weaver herself. I heard her say that she wants one of them, so, well, I went out and made one. The hand turning was really just on this handle part that I made to, well, look like a column. This was my setup for machining the flutes on this handle. I just set it back up after I cleaned off the table. Nothing's bolted down, but the setup was just like this. This is one of those hard-inch direct indexing fixtures, and there are 12 flutes in the part here. With this much stick out, the footstock was definitely needed to keep the part from flexing. Here is my setup for cutting all the spaces between the teeth of the comb. And how I'm doing it is I've clamped this large parallel to the combination square, and I've decided that's the fastest and easiest way for me to get 1/8 of an inch distance between each cut while keeping it square. And it's doing very well. I have one last tooth to do and then a little bit of cleanup, but all the teeth are nice and neat, square, and mostly the same size. Originally, I wanted to do it on the horizontal mill because I just want to do everything on the horizontal mill. And the plan was to use 3 of these slitting saw cutters ganged up like this. That would have made a very even and very regular and clean cut, especially on the inside of the cuts. But it would have also limited the depth of each tooth to about 1/2 inch, and doing it how I do it on the bandsaw got me a longer tooth. You know, the nice thing about polishing is that it makes all your mistakes look not only intentional but correct. This here is a early concept drawing of it. Some of the features are the same dimensions, but a lot has changed in the appearance of it. I hope you've enjoyed seeing some of my hand-turning projects. I had a lot of fun making these things. You know, hand-turning on the lathe is one of those things that once you figure out how to do it, it's almost like you've got another machine. Anyway, I'll catch you later.